Hello, good morning or slash afternoon, gentlemen. This is Miss Arsoli. And if you are listening to and watching this, that means we have decided to try something new in math class. So as you see in front of you, this is your copy of lesson 3 from unit 4. That is the lesson we have been working on. And today, instead of us doing our normal groups, I'm going to record myself teaching this lesson. You're going to follow along and listen at your own pace. The hope is that everyone is able to stay super locked in and focused. And while you guys are working, Miss Stewart and I are going to be able to circulate to check in and answer questions. Hopefully this means we will get through the lesson more quickly, and then we will have more time for things that are a little more fun and engaging. So let's go ahead and get started. You should be flipping to the objective. Our objective for this lesson is that you'll be able to find and use constants of proportionality. So we've been learning about COP and proportional relationships. We've been building on that from the 6th grade stuff, and we're going to continue to use the COP to solve problems. And what makes the problems in this unit a little more difficult is that we've added fractions. So with this problem, most of you got to start on this, and some of you finished this. So we're not going to do this together, but I do want you to go down to the bottom of the page where it says notes. And if you don't have these notes in, you should write them along with me. And if you do, this is just a quick review. So it says, even though the table had fractions, we can still find the COP by doing y over x. Then we can use the COP to complete the rest of the table. If you need extra time to write this down, please pause the video here and then hit play when you're ready. If we go back up to look at this table, the strategy that we used was finding the COP and using the COP to fill in the table. So just like we said with the note-taking part, to find the COP, you had to do y over x. So you always want to make sure you understand which numbers represent the y, which represents the x. Take a second to think about it, see if you know it. And in this example, sugar is the x, flour is the y. The x numbers are always going to be in your first column, while the numbers that represent y are always going to be in your second column. Even if we had a table that was going horizontally, so if we had a horizontal table, something like this, our x would still be first and then our y. So all the numbers in this column would represent x, all the numbers in that column are y. All right, so let's go ahead and scroll down to, or I should say you guys should turn to the next page, which is, it says number 2, and it has my notes on there. And for this, we're gonna look at 2 different methods, 2 different ways to solve problems. The first one is Karan's method, and that's this table on the left. The second is Priya's method, and that's this table on the right. So before I tell you what the different methods are, I want you to stop and think, what do you notice about the 2 different methods? What's something that you see? And the video is going to pause, a question is going to pop up, and I want you to put your answer. Something I notice about Karan's method is, something I see that Priya did is, and you can use K and P because I know their names are a little bit probably difficult to spell, so if you just want to use K and P, that's fine. All right, now let's go ahead and see what the different methods are. So first, for Karan's method, I see he went from 6 to 1 first by multiplying by 1/6. If you remember from the beginning of the last unit, multiplying by 1/6 is the same as just dividing by 6. So when I see that he did 6 divided by 6 to get 1, that tells me that, oh, he's actually finding the unit rate. So we're going to call this one the unit rate method. After he found the unit rate, so he went from 6 feet of rope that cost $7.50. He divided 6 divided by 6 to get 1 foot of rope, and $7.50 divided by 6 to get $1.25. So now we know 1 foot of rope costs $1.25. The next step that we're going to do is figure out how much 50 feet of rope would cost. And we're going to do that by first, well, what Karan did is to go from 1 to 50, he multiplied by 50. And he knew he had to do that on both sides. So 1 times 50 is 50. To figure out how much 50 feet of rope would cost, we will need to do $1.25 times 50 to get our answer. So please pull out your calculator and type this along with me. 1.25, excuse me, make sure you have that calculator up and make sure you're typing, times 50 equals 62.5. So we can put that in our table. And this means that 50 feet of rope costs $62.50. Please take time right now to make sure that you have these notes. You can pause the video if you need to and then restart it once you have the notes. All right, now we're going to look at our second method. The second method, which is what Priya used, I see there's only 2 rows in this table as opposed to the 3 that were in Karan's. So this means it's just one step. What she had to do first was find the COP, and then she's able just to use that to fill in the table. So this second method, I'm going to extend my table so that I can find the COP. We know that to find the COP, we have to do, hopefully you're saying y over x to yourself. And then I know I want to make sure I'm identifying the correct numbers that are y and the correct ones that are x. So I'm just going to label my columns really quickly. I know all the numbers in this column represent x, and all the numbers in my right column represent y. So if I'm doing y over x to find the COP, that means I have to do $7.50 divided by 6. So let's go ahead and get our calculator out. Make sure you're typing along with me. 7.50 divided by 6 equals 1.25. That means my COP is 1.25. So to go from x to y, I need to times by 1.25. So now I can easily solve this, and I can easily figure out how much does 50 feet of rope cost by doing 50 times my COP, which is 1.25. So I'm going from x to y by multiplying by my COP, which we found is 1.25. So again, get that calculator up and type along with me. 50 times 1.25, because again, we're following our arrow. So going from 50 times 1.25 to get our answer, and we get 62.5. If I think, or let me say what this means. So this means that 50 feet of rope costs $62.50. Is that the same answer that we got when we used the unit rate method? Yes, it is. So you might be thinking, Ms. Arsoli, why do we need to learn this? Why do we have to learn 2 different methods? What does this matter? When are we going to use it in real life? This is important because anytime you are trying to solve a problem, it might be a money problem, it might be something you want to buy, it might be when you get a job and you're trying to find the best buy for your company, you have to be able to look for patterns and then apply it to a situation. And this shows us that you can use multiple, there's different methods you can use. And that's important because that means you don't have to use a set method. You can think about which one you like better or which one you prefer, which one makes more sense to you. So for our notes, we saw that Karan used the unit rate method. So that was this first one. He found the unit rate and then he used equivalent fractions to find how much 50 feet of rope would cost, or to solve the problem. That was the first method. Priya, on the other hand, found the COP and used that to solve the problem. Both methods work. So I want you to think about what your preferred method is. Which one do you like better? And on your paper, you are going to write that down. My preferred method is you're going to write unit rate or COP because blank. Please take a few minutes to completely answer this question on your paper. Pause the video here so that you don't miss the next part while you're writing, and then hit play whenever you're ready to move on to the practice problems. All right, now we're going to use our preferred methods to practice the problems below and to complete them. On question number 1, I'm going to set it up for the COP method. You can follow along and do the COP method. If you want to use the unit rate one, you can do that as well. For number 3, I'm going to use the unit rate one. Again, you can follow along and use the unit rate one, or you can use the COP if that's your preferred. And then for questions 2 and 4, you're going to do those on your own. Ms. Stewart and I, again, will be walking around to help, so if you get stuck or if you have a question, please raise a silent hand. Please don't call out. That's going to distract me. It's going to distract others. It's going to throw us off our game, and right now we're trying to stay locked in, so please make sure you're just raising a silent hand. All right, question number 1. With any problem, whenever you're trying to solve it, you should always read it first. You all know how to solve these problems. You have to set yourself up to be successful by always reading the problem first. Plug those headphones in, hit the read aloud, raise your hand and ask us to read it for you. This is something that will help you process so you understand what the question is asking. Question number 1 says, Tyler swims at a constant speed, 5 meters every 4 seconds. How long does it take him to swim 114 meters? So first, I'm going to highlight the information that we're given. 5 meters for every 4 seconds. That's the ratio. I'm also going to highlight the question that we're trying to ask. How long does it take him to swim 114 meters? To use the COP method, normally I would extend my table. We don't really have that here, but I know to find the COP, I just have to do my Y over X. So I can easily do that in my workspace below the problem. I just want to remember to label my columns first so I know how to set my problem up. All right, so for the COP, I am doing Y over X. In my problem, I see that the 4 is in my Y column. So when I'm doing Y over X, I'm doing 4 over 5. Anytime you have a fraction like this, this is division. Please look up at the front of the room, right above where it says strong finish. There is a pink and black sign that says division signs. You should see A over B. That means A divided by B. So in this case, we have 4 over 5. That means 4 divided by 5. Again, pull that calculator up. 4 divided by 5 is 0.8. 0.8 is my COP. That means to go from X to Y, I have to times by 0.8. So to find my answer, or to find how long it would take Tyler to swim 114 meters, I do 114 times 0.8. Again, we have to follow that arrow and use our calculator. So in my calculator, I'm going to start with the 114 that I have. I'm following my arrow, which tells me I have to multiply by 0.8, and that will give me the time in seconds. So please make sure, whoops, I wasn't supposed to give you the answer. Please make sure you're writing that in your table, the 114 times 0.8, and whatever you get, you should put up here. That was another example of the COP method. So you should be thinking, do you like that one better, or do you want to try a different method? Pause the video here to make sure you have all of your notes. Make sure you have that answer recorded, and then you can hit play to solve the next problem. For problem number 3, I'm going to solve this one using the unit rate method. For the unit rate method, we will have to show lots of work. I also see a fraction here, so I know that this might not be enough space to show all of your work. Please raise a silent hand at this time to get a blank sheet of paper from Ms. Sarasoli or Ms. Stewart so that you can show all of your work. I'm actually going to give myself some more room on the screen as well. All right, so just like with any problem, we want to read it so that we know what it's asking for. This one says a certain shade of light blue paint is made by mixing 1.5 quarts of blue paint with 5 quarts of white paint. How much white paint would you need to mix with 4 quarts of blue paint? So again, I'm highlighting the information I'm given, that ratio. I know that to make a blue color, I need 1.5 quarts of blue paint, 5 quarts of white paint. 1.5 to 5, that's my ratio. Then I'm going to highlight the question that it's asking. How much white paint do we need to mix with 4 quarts of blue? Excuse me. All right, so now we got to set our problem up. I said for this one, I'm going to use the unit rate one. So I'm going to set my unit rate problem up. Boom. Because I know I'm trying to figure out how much white paint I need if I have 4 quarts of blue, I'm going to set this problem up as white to blue. So now I need to put my information in there. I have 5 quarts of white paint to 1.5 quarts of blue. If I'm finding my unit rate, I know I'm trying to go from 1.5 to 1. You should be thinking to yourself, what do I have to do to 1.5 to get to 1? And hopefully you're recognizing it's divide by 1.5. And if I'm dividing by 1.5 in my denominator, I also have to divide by 1.5 in my numerator. So now I'm going to write my problem over here in this space so that I can keep everything nice and organized. For you, you can write it on the blank sheet of paper that you should have asked for from Ms. Sarasoli and Ms. Stewart. All right, so let me follow my arrow to write my problem. I'm starting with 5. That's where my arrow starts. Then I see as I follow my arrow, it's telling me to divide by 1.5. So I have 5 divided by 1.5. As soon as you see this problem, we're dividing fractions. This should tell you that we have to use a certain strategy, a certain algorithm. By now, hopefully you're saying, Ms. Sarasoli, we got to use keep, change, flip. In order to do that, I first need to make sure I have everything written as a fraction. So first, 5, because that's a whole number, I can easily write that as a fraction by just doing 5 over 1. Every whole number has a denominator of 1. If you ever forget, you can look at the 6th grade word wall. Divided by Now, here I have a mixed number. I have a whole number with a fraction. In order to rewrite this as an improper fraction so that we can do keep, change, flip, step number 1, you got to take your denominator and you're multiplying it by the whole number. So you're doing 2 times 1. I know 2 times 1 is 2. Then I need to take that answer and add it to my numerator. So I'm doing 2 plus 1. Well, I know 2 plus 1 is 3. So 1 and 1/2 can also be written as 3/2. They are equivalent. We're just writing 1 and 1/2 in a different way. So now, for my problem, I have just fractions. 5 divided by 1/2 is the same as 5 over 1 divided by 3/2. But now I can easily do keep, change, flip with how I rewrote it. So I'm going to show my work over here. For keep, I know I have to keep my first fraction the same. 5 over 1 stays 5 over 1. Boom. My division changes to multiplication. And then my final fraction I have to flip. So instead of 3 over 2, I have 2 over 3. Hopefully by now you're recognizing, we're just we're multiplying fractions. And when we multiply fractions, we just multiply across. So to get my answer, I would have to do 5 times 2 to get my numerator, 3 times 1 to get my denominator. Please go ahead and put that answer on your paper, and then go ahead and try problems 2 and 4. Please remember to raise your hand silently if you need anything. Once you are done with problems 2 and 4, you will be moving on to partner practice for probably about 10 minutes. You have a lesson on pair as well that can help you through it. You can work with a partner on these problems. Then we will do the exit ticket, and hopefully we will have time for something fun like a Book It or a Kahoot.